Day 3, we're going to be working on rectangles, rhombi, and squares. And now, I say rhombi, there are actually two accepted plurals. You can have rhombi or rhombuses, either work. Rhombuses, I'm not sure about that one. But rhombi is also accepted. Now, I want to go ahead and point out from this diagram that I drew yesterday that rectangles, rhombuses, and squares are all special cases of parallelograms. So all of the properties of parallelograms that we already talked about are going to apply to our rectangles, rhombuses, and squares as well. Hey guys, remember I'm recording a video. Shh. Sorry, y'all. It's in-service day and I've got my kids in my classroom with me. Okay, where was I? Oh, yes. So rectangles, rhombuses, and squares, all the properties of parallelograms are going to apply to them as well. So here are all of our properties. We're going to start off with rectangles. Okay, first off, you know that opposite sides are parallel and opposite sides are congruent. Those are our two sides for... Oh, I wrote that in the wrong spot. Opposite sides are congruent. Those are properties from parallelograms. Also, we know opposite angles are congruent. And we know that consecutive angles are supplementary. Now, we also know that the diagonals bisect each other. It's all my properties from parallelograms. Now, also, new for rectangles is that all four angles are right angles. So we know that here angle T, U, S, and R must be right angles. And I also know that diagonals are congruent. Now, that's not true for general parallelograms, because if I look at both of these diagonals, I can obviously see that TR is going to be larger than QS. For a rectangle, they will be exactly congruent. Okay, so for number 1, we've got RUTS is a rectangle, and it tells me that US is 6x plus 3. And RT is 7x plus 2. Now, since this is a rectangle, then I know that those are congruent, so I can set them equal to each other. So 6x plus 3 equals 7x minus 2. All right, let's go ahead and collect things on the same side, get rid of those x's. We're going to get rid of this 2. And that is going to leave me with 7x minus 6x is just x. And then 3 plus 2 is 5. So 5 is equal to x. All right, number 2. RUTS is a rectangle. STR, so STR, this angle here is 8x plus 3. UTR, this angle here is 16x minus 9. Now I want to find the measure of angle STR, so I want to find the measure of this angle. Now we make sure we realize, since it's a rectangle, this together combined, that doesn't look very good, is 90 degrees. So the two of those together are complementary. So 16x minus 9 is equal to, plus 8x plus 3 is equal to 90. Well, let's combine our like terms. 16x and 8x makes 24x. Negative 9 plus 3 is minus 6 equals 90. Now we're going to add 6 to both sides. That gives me 24x is equal to 96. And now 96 divided by 24 tells me that x equals 4. Now, don't take the bait and think that you're stop there because you think that you're done, because we want the measure of the entire angle. Measure of angle STR is equal to 8 times x plus 3. Now I replace the x with the parentheses because we got to substitute in our 4 there. 8 times 4 plus 3 tells me that the measure of angle STR is equal to 35 degrees. Okay, number 3, quadrilateral ABCD is a rectangle. BE, which is this one, is 6y plus 2, and CE is 4y plus 6. Now, this is going to combine two of our properties. I know that diagonals bisect each other, and I know that on a rectangle, the diagonals are congruent, so all 4 of these must be congruent to each other. So in this case, I know BE equals EC. That's only going to happen on a rectangle, not on other types of parallelograms. So I can go ahead and just set up 6y plus 2 is equal to 4y plus 6. Now, let's see, I'm going to subtract 4y on both sides, making those go away. I'm going to subtract 2, making those go away. It leaves me with 2y is equal to 4. Now divide both sides by 2, and y equals 2. Moving on, number 4. Determine whether or not it is a rectangle. Okay, we got to do 2 things here. We got to know, number 1, is it, or do we have a right angle, or do we have right angles? And number 2, we got to decide, are my, or I can do, are my diagonals congruent? The easiest one, honestly, is to decide whether or not the sides are perpendicular to each other. And we're going to do that by looking at our slopes. So we're going to find all 4 slopes here. Here, my slope is rise of 3, run of 1. Okay, right here, again, I've got a rise of 3 and a run of 1. Now, when those 2 are equal to each other, that tells me that for parallel lines, slopes are congruent. So I know that BA is parallel to CD. That's good. Now let's go ahead and check our slope over here. Oops, I went the wrong way. Need my rise and my run. Here my rise is 2, my run is 1, 2, 3, 4, 5, 6. So my slope it's falling, so it's negative 2 over 6, which reduces to negative 1/3. Let's do the same thing over here. Again, we've got a rise of 2, a run of 1, 2, 3, 4, 5, 6. So a slope of, again, it's negative 2 over 6, which the same reason reduces to negative 1/3. So now I know that these 2 are congruent. So BC and AD are parallel. Now, let's look at our 2 slopes, the ones in green and the one in purple. We've got 3 over 1, and we've got negative 1/3. Which those are opposite reciprocals. Okay, it's been flipped upside down. One's positive, one's negative. That means perpendicular. So yes, these are going to be right angles on all of them. So I've got parallel opposite sides. I've got 4 right angles. Yes, this is a rectangle. If that was any other pattern besides the 3 over 1 and negative 1/3, if it was not opposite reciprocals, it would not be a rectangle. Okay, properties of rhombi. A rhombus is a quadrilateral with 4 congruent sides. Now, a rhombus is also a parallelogram, so all those properties apply. Opposite sides are congruent, opposite angles are congruent, all the ones we did before. Now, except the rectangle properties. Rectangle properties do not apply here. Now, we've got 2 additional properties beyond a parallelogram, and that is that diagonals are perpendicular. That's why I've got my right angle right here. Okay, they hit at a right angle, forming 4 right triangles inside of the rhombus. Also, each diagonal will bisect a pair of opposite angles. Now, that's why over here, notice that these two both have two arcs in it, and these two have two arcs in it. It's because all four of those angles are going to be congruent because RO bisects angle MRH. And the same idea that these four angles are congruent to each other here. Okay. So let's see. In rhombus ABCD, measure of angle BAC is 32, already marked right here. Find the measure of each numbered angle. So we got measure of angle 1, measure of angle 2, measure of angle 3, and measure of angle 4. Okay, the easiest one here is going to be angle 4 because diagonals are perpendicular. That one is automatically 90 degrees. Now, I've also got that since the diagonal bisects opposite angles, all four of those are congruent. So, well, up on the top one, all four of the green ones are congruent. Same idea here. So angle 3 is also going to be 32 degrees. Now, to find the measure of angle 1 and 2, they're going to be equal to each other because of the fact that that rhombus, or the diagonal, bisects angle ABC. But we're going to use this triangle ABE to find it. So we know that 32 plus 90 plus angle 1 is equal to 180. So we're just going to add 32 and 90, then subtract that from 180. So the measure of angle 1 is just, oh, I messed up there. 180 minus 122 is 58 degrees. And both of those are going to be 58 because they are congruent. Okay, number 6. It tells me that AB is 26. BD is 120. So the whole diagonal is 120. There's 20. I'm going to write that as 10 and 10 just to make that easier to keep track of because I know the diagonal is bisected. Find AE. Well, I know that this is a right triangle or a right angle. Therefore, I've got a right triangle, so I can use Pythagorean Theorem to find AE. Now, Pythagorean Theorem, if you don't remember, is A squared plus B squared equals C squared, where C is the hypotenuse, or that is C, the 26. I need to stop highlighting green and blue together. They don't work well. Okay, so we're going to plug in. A is going to be 10 squared plus B squared equals C squared, which is 26 squared. Okay, so I know 10 squared is 100 plus B squared. Now 26 squared is 676. I'm going to subtract 100 from both sides. Leaves me B squared is equal to 576. And then I'm going to do square root of 576 is 24. So AE is 24. Okay, that's it for my rhombuses and rectangles. Now let's move on to squares. And a square is actually the simplest one of them all because it is both a rectangle and a rhombus, which means all the properties apply. Now, the reason I say it's the simplest one is because everything is equal here. I mean, we've already got these sides right here. Those are all congruent. All of these are congruent. We've got 4 right angles on the inside, and all of these angles that I'm marking here in green, those are also congruent. And more than that, every single one is just 45 degrees. So it's a very simplistic shape. When I say simplistic, I mean not that difficult to memorize and remember what's inside it. It has a lot of structure to it. But let's see, it says WT is equal to 3. find the rest of them. Now, the beauty of a square is that when I know one thing, I pretty much know everything. So, ZX, well, if TW is 3, then TZ is also 3, and XT is also 3, so XZ, the full distance, is 6. Okay, measure of angle WTZ. WTZ is this angle here, which I know is a right angle. That's 90 degrees. XY, well, XY here, if XT is 3, YT is also 3, so I can do Pythagorean Theorem again. Here's my right angle. I can do Pythagorean Theorem with 3 squared plus 3 squared equals XY squared. Well, 3 squared is 9, plus 9 equals XY. 9 plus 9 is 18 equals XY. I forgot the squareds on there. So now I take the square root of both sides, and square root of 18 is just 4.24. Okay, measure of angle WYX. Well, WYX, I'm going to mark here in purple, is right there. That's exactly half of the full angle, the full 90, so it's just 45 degrees. Okay, number 8, determine whether or not it's a rhombus, rectangle, or square. Okay, first thing I'm going to do here is I'm going to calculate all of the slopes, and the slopes are actually going to give me some information about the side lengths, and I'll show you what that means here in a minute. Okay, so I'm going to do my rise and my run for BC. My rise is 1, 2, 3, 4, and my run is 1, 2, 3, 4. So my slope is negative 4 over 4, which is negative 1. Now I'm going to do the exact same thing over here. 1, 2, 3, 4, 1, 2, 3, 4. So my slope is negative 4 over 4, so my slope is negative 1. Now, that tells me two important pieces of information. It tells me first that these guys in blue are parallel. It also tells me that they are congruent. The reason I know it's congruent is because since the rise and the run are exactly the same, that means I could do distance formula or Pythagorean theorem to find this distance here, but I don't really have to find it because I don't care how long it is. All I care is that they are equal to each other. And I know that because the A and the B would be 4, 4, and the C value would come out the same because Pythagorean theorem would be the same on both of those. Okay, let's do this one over here. Here my rise is 1, 2, 3, 4, 1, 2, 3, 4. So I've got the slope is 4 over 4. This one's positive, which is 1 over 1. Down here, I've got 1, 2, 3, 4, 1, 2, 3, 4. So here my slope is, again, 4 over 4, which is going to be 1 over 1. And now, again, that tells me that the slopes are equal. Therefore, those in orange are parallel as well. And I know they are also congruent because of the fact that, again, the A and B value for Pythagorean theorem would come out the same. And just in case you're wondering what I mean there, I literally mean if I did 4 squared plus 4 squared equals C squared, this is going to be equal. Also, another thing that I can tell here is that all the sides are going to be equal to each other as well, because again, I've got nothing but 4s. In orange, I would also have 4 squared plus 4 squared equals C squared. I know that these are going to be the same as well. So all 4 sides are equal. Tells me I have a rhombus. But don't stop there, because whenever I look at the slopes, again, I've got a positive 1 over 1 and a negative 1 over 1. Now, that looks to me like those are opposite reciprocals. That implies that they are perpendicular. So in particular, these 4 are also right angles. So all right angles, that implies I've got a rectangle. But if I've got both a rectangle and a rhombus, then that means I have a square. Okay, So we're just checking for every single property. When I see all of them, then that means I've got a square. All right, good luck on the assignment. Feel free to reach out. Let me know if you have any questions.